Hello students, welcome to Mathematics Study channel. In the last class we discussed about continuity and differentiability. We have already completed exercise 5.7. Today we are going to discuss exercise 5.8. Before going to start exercise 5.8, we know about some theorems. First theorem is Rolle's theorem. So what is the Rolle's theorem? The statement is, if a function fx is number one condition continuous in the closed interval a comma b, number 2 derivable in the open interval a comma b, and number 3 f of a equal to f of b. If these three condition is satisfied, then there exists at least one real number c in open interval a comma b such that f dash of c equal to 0. This is the Rolle's theorem. So first a given function is given. First eta function here dia thakibo. First of all a function is given. So first we check it is continuous or not. Secondly we check it is differentiable or not at a given point. Number 3 condition is the f of a and f of b are equal or not. We have checked these three. If three condition is satisfied, then there exists at least one real number which is belongs to in a given interval, then f dash of c equal to 0. এইটোৱে কি Rolle's theorem. তো Rolle's theorem to কেনেকৈ ভেৰিফাই কৰিব লাগে আমি এটা এক্সাম্পল লৈ লৈছো প্ৰথমতে. ফাৰ্স্ট আমি এটা এক্সাম্পল লৈ চাই আছো যে ফাৰ্স্ট এক্সাম্পলটো লৈছো exercise 5.8 or 1 number problem to jitu ase ei example to lisu je verify Rolle's theorem for the function fx. So first one, let's try to verify the given function is what fx equal to x square plus 2x minus 8. It is given function. So it is what type of function? It is a polynomial function. So interval is also given here where x belongs to what, where x belongs to open interval minus 4 comma. It is given. So it is seen that this is a polynomial function, and we know that every polynomial function is continuous as well as differentiable. So since it is a polynomial function, so it is continuous as well as differentiable. So since f of x is a polynomial function, since f of x is a polynomial function, so number 1, f of x is continuous, on open closed interval 4 comma 2. So number 2 condition, it is differentiable also. The f of x is derivable on open interval a comma b. Also now we are going to check f of minus 4 and f of 2. That at x equal to minus 4 point ইয়াৰ যেটো ভ্যালু লাগো and at x equal to 2 পইণ্টত যেটো ভ্যালু লাগো এই ভ্যালু দুটা সেম হয়নে নহয় এটো হে আমি এতিয়া চেক কৰিম. Now we are going to find f of minus 4. So f of minus 4 equal to the function is given here 4 square plus 2 into minus 4. This is equal to, this is 16 minus, maybe minus 8 is also here. So minus 4 square is 16 minus 8 and minus 8. This is equal to 16 minus 16. This is equal to 0. Now we are going to find f of 2. So f of 2 equal to what? Put x is just replaced by 2. Then this is 2 square plus 2 into 2 minus 8. This is equal to 2 by 2 4 plus 4 minus 8. This is equal to 8 minus 8 equal to 0. So what we had f of minus 4, this is equal to f of 2. So all the condition of Rolle's theorem are verified here. satisfied here. So here all the condition of Rolle's theorem all the condition of Rolle's theorem are satisfied. So there exists at least one real C such that real C belongs to open interval minus 4 comma 2 such that f dash of C equal to 0. So since f of x is given here, so f of x is what? F of x is x square 2x minus 8. So if we differentiate this, then we get f dash of x equal to what? F dash of x is ddx of x square 2x minus 8. So ddx of this is equal to what? We can find 2x plus 2. Okay, ddx of this. Since C belongs to minus 4 comma 2 such that f dash of C equal to 0. So now therefore f dash of C equal to 0. So in place of x, if we put C, then what we get? The value of this is equal to this. So we can write 2C plus 2 equal to 0. That implies that 2C equal to minus 2. That implies C equal to minus 1. And minus 1 lies between minus 4 comma 2, which belongs to what? Which belongs to open interval minus 4 comma 2. Thus what we have, thus f dash of minus 1 equal to 0 and minus 1 belongs to this minus 4 comma 2. Hence Rolle's theorem is verified. Rolle's theorem is verified with C equal to minus 1. We are going to solve question number 2. So question number 2 is what? Examine if Rolle's theorem is applicable to any of the following function. Can you say something about the converse of Rolle's theorem for the given example? So question number 1, fx is given. Fx is equal to x, greatest integer x, for the condition is x belongs to closed interval 5 comma 9. So 5 comma 9. It is a greatest integer function, and we know that greatest integer function is not derivable at integral point. So jibula greatest integer function take, it is a greatest integer function. So we know that the greatest integer function bila ki nohoy differentiable nohoy. যেহেতু এটো differentiable নহয় তেতিয়াহলে ইয়াৰ পৰা আমি গম পাই যাব লাগিব কি এটো Rolle's theorem to হয়তো কি যেটো Rolle's theorem ৰ যিখিনি কন্ডিশন আছে এই গুটেখিনি কন্ডিশন হয়তো স্যাটিসফাই নকৰিব পাৰে। তো আমি এটো this type of question how to solve, since it is a greatest integer function, so this is not differentiable. If it is not differentiable, then it is not continuous also, because if a function is not differentiable, then it is never be continuous. So since the function f is neither continuous nor differentiable since the function f is neither continuous nor differentiable at integral point, what is the integral points? Integral points are given here 5 to 9 at integral point, that is what 5, 6, 7, 8 and 9 okay. So fx is not continuous, so fx is not continuous on closed interval 5, 9. Since fx is not continuous on closed interval 5, 9, then it is not differentiable also. So then it is not differentiable. On open interval 5, 9. Also, this is open interval, sorry. Also f of 5, this is equal to greatest integer 5, the value of this is 5, and f of 9 equal to what? F of 9 equal to greatest integer 9 equal to 9. Also f of 5, therefore f of 5 not equal to f of 9. So Rolle's theorem or কোনো condition है कि यात satisfied करा नहीं. So hence Rolle's theorem is not applicable. Rolle's theorem is not applicable to the function fx, to the fx in interval QSL, interval QSL 5, 9 in 5, 9 যে ইয়াত কি নহয় applicable নহয়, and it may be noted that f dash of x equal to 0, and it may be noted that f dash of x equal to 0 for all non-integral integer interval to আমার কি আছিল non integral points, right here, non-integral points 5, 9. This shows that the converse of Rolle's theorem, converse of Rolle's theorem is not true. Okay, so question number 2 and 2 is same with question number 1. Now we are going to solve question number 3. So question number 3 is 2, 3. F of x is equal to x square minus 1 for x belongs to what? For x belongs to closed interval 1 comma 2. So let's try to solve. It is a polynomial function. So f is continuous. So f is number 1. So f is continuous and differentiable at all x belongs to R. At all x belongs to R. এই ইন্টারভেলত থকা গোটেইখিনি পয়েন্টৰ কাৰণে এটো কি হ'ব? কন্টিনিউয়াস হ'ব and কি হ'ব? ডিফারেন্সিয়েবল হ'ব. In particular f of x is continuous. F of x is continuous on closed interval 1 comma 2 and differentiable on open interval 1 comma 2. But what is what? But f of 1 is equal to what? F of 1 equal to 1 square minus 1 equal to 0, and f of 2 equal to what? F of 2 equal to 2 square minus 1. This is equal to 4 minus 1 equal to 3. Here we see that f of 1 not equal to f of 2. Hence, Rolle's theorem is not applicable. Rolle's theorem is not applicable to the given function on the closed interval what? 1 comma 2. Okay, note that f dash of x equal to what? Since x square, f of x equal to what? F of x is what? F of x equal to x square minus 1. If we differentiate this, then we get this is equal to 2x, which is not equal to 0. Okay, note that f dash of x equal to 2x, which not equal to 0 for any x belongs to 1 comma 2. অর্থাৎ 1 comma 2 ৰ ভিতৰত এনেকুৱা কোনো পয়েন্ট নাই যেটো পয়েন্ট ইয়াত পুট কৰিলে কি হৈ যাব? f dash of c ভ্যালুটো কি 0 হৈ যাব. তো এটোৱে কি যেহেতু রোলস থিওরেমটো কি অ্যাপ্লিকেবল নহয়, তো এইখিনি আছিল আমাৰ आंसर. Now we are going to solve question number 3. So question number 3 is what? Question number 3 is if f from closed interval minus 5 comma plus 5 to ইয়াত এটা ফাংশন ড্ৰ কৰিছে to r. This is f from minus 5 comma 5 to closed interval to r. Okay, is differentiable function and f dash of x does not vanish anywhere, then prove that we are to prove that f of minus 5 not equal to f of 5. It is given f from minus 5 comma plus 5 to r is a differentiable function and f dash of x does not vanish anywhere, then we are to prove f of minus 5 not equal to f of 5. So let's try to solve. If we suppose f of minus 5 equal to f of 5, then f would satisfy all the condition of Rolle's theorem. যদি আমি এনেকৈ ধৰি লও f of -5 equal to f of 5 তেতিয়া হলে কি কৰিব f এ Rolle's theorem ৰ গোটেইখিনি কন্ডিশন স্যাটিসফাই কৰিব how এটো কেনেকৈ কৰিব since it is given that this function is differentiable and we know every differentiable function is always continuous, so since it is a differentiable function so it must be continuous function. Since all the condition of Rolle's theorem is satisfied, then there exists at least one real number C belongs to this interval -5, such that f dash of C equal to 0, but according to question, but in the question it is given what is given in the question it is given f dash of x does not vanish anywhere, but f dash of x, but in the question f dash of x does not vanish anywhere, but f dash of x does not vanish anywhere, therefore our supposition is wrong. If our supposition is wrong, then f of -5 not equal to f of 5 as proof. Now we are going to take another example of Rolle's theorem. To verify Rolle's theorem for the function, the function is what? It is extra question. F of x is equal to what? F of x equal to x cube minus 9x square plus 26x minus 24 plus 26x minus 24, and x belongs to what? And x belongs to, in the interval is given here, where x belongs to, it is given here, x belongs to 2, 4. In the interval 2, 4. So let's try to verify Rolle's theorem. It is a polynomial function. It is a polynomial function. So if it is a polynomial function, so f is continuous and differentiable at all x belongs to R. Particularly in this problem, f is continuous on closed interval 2, 4 and f is differentiable on open interval 2 comma 4. Also f of 2 equal to what? F of 2. So x is replaced by 2. This is 2 cube minus 9 into 2 square plus 26 into 2 minus 24. The value of this is 8 minus 2 by 2 4, 4 by 9 36 plus 52 minus 24. This is equal to, this is 60. This is equal to 60 minus 60 is equal to 0. Okay. So this is equal to 0 and f of 4 is equal to 4 cube minus 9 into 4 square plus 26 into 4 minus 24. This is equal to 4 cube 64 minus 4 by 4 16. 16 into 9. 16 into 9 is what? 16 into 9. So 16 into 9. 6 by 9 54. 9 1 by 9 5 14 144. This is 144. Okay. 144 plus 26 by 4. 6 by 4 24. Okay. And 2 by 4 8. 8 10 minus 24. This is equal to 0. Thus we have f of 2 equal to f of 4. Therefore f satisfied all the condition of Rolle's theorem in interval 2 comma 4. Okay. Then there exists at least one real C belongs to open interval 2 comma 4 such that f dash of C equal to 0. Now f of x equal to what? F of x equal to, it is given f of x equal to what? F of x equal to x cube minus 9x square plus 26x minus 24. If we differentiating this, then f dash of x equal to, this is 3x square minus 18x plus 26. Okay. Now f dash of C equal to 0. That implies, so x is replaced by c, then 3c square minus 18c plus 26 equal to 0. Here we get a quadratic equation. Okay. So this is a quadratic equation. So let's try to solve here. Here c equal to, the quadratic equation is what? Minus b. So minus b is minus, b is minus 18. Okay. So plus minus is square root of what? Square root of b square minus 4ac. So b is minus 18. So right here minus 18 whole square minus 4. A is 3 and c is 26. Okay. Divided by 2a. 2 into a is 3. Okay. So this is equal to what? This is equal to 0. This is equal to 0. Okay. This is equal to 0. Not 0, sorry. So this implies that C equal to 18 plus minus square root of 18 by 18 equal to 324. Okay, 324 minus 3 by 4 12, 12 by 26 equal to 312. Okay, 312 divided by 6. This implies that C equal to 18 plus minus square root of this minus this, 4 minus 2 is 2, 1 minus 2 minus 1 is 1, and here is nothing, so this is 6. Now this is equal to C equal to what? C equal to 6, 18 plus minus, so square root of 12 is 2 root 3. Okay, 2 root 3. So this is equal to C equal to, dividing each term by 2, then this is 9 plus minus root 3 divided by 3. This implies that C equal to, this is not X, this is C, sorry. So C equal to 3 plus minus 1 by root 3. Okay. So value of C is therefore C equal to either 3 plus 1 by root 3 or C equal to what? Or C equal to 3 minus 1 by root 3. Okay. So we get the value of C, 3 plus 1 by root 3, which is less than 4, and 3 minus 1 by root 3, which is also less than 4, but it must be greater than 2. Therefore, both 3 plus 1 by root 3 or 3 minus 1 by root 3 lies in closed interval open interval 2 comma 4. Okay, so thus Rolle's theorem is verified. Okay.